P and IDs, or in other words, piping and instrumentation diagrams, are considered as a key document when designing or upgrading any process plant. Through the P and IDs, we are supposed to be aware of how the plant shall operate. A well-designed P&ID preparation would lead to a smooth project execution. In addition, it shall identify main risks. This would reduce the probability of issues when running the plant. If we want to know the process parameters that shall be monitored, we can simply open the P&IDs. Let's take this vessel as an example. So, if we see a level glass on a vessel like this shall mean that the operator can know the liquid level in the vessel if he goes to the field and checks out the reading there from this level glass. However, if this level glass was a level transmitter, this means that it shall be connected to the control system, which is the DCS, or in other words, distributed control system. This means that the operator can see the level reading from the control room, and if this level transmitter has a low level alarm, for example, then this shall mean that the operator shall receive an alarm in the control room when the level is below a certain value, or we shall receive a high level alarm in case the level was above a certain value. If this level is used as a control parameter, then we shall see this level transmitter connected to a level control through an input signal, and the controller shall then process the reading and give an output. Based on the controller output, this shall send an output signal to the control valve, which adjusts its opening to keep the level in the vessel at the required set point. If this level instrument is used to protect the system from very low level, then in this case, we shall see the transmitter connected to the emergency shutdown system, or in other words, ESD. The ESD receives a very low level signal, and based on this signal, it shall send an output signal to close this shutdown valve, or in other words, on-off valve. So we should show any shutdown actions that are expected to be triggered in case of very high or very low level pressure, temperature as applicable. The P&ID is also supposed to show how this vessel is protected. That's why it's common practice to show its design pressure and temperature. If there is a pressure safety valve on the vessel which shall send the relief load or the load resulting from overpressure to the flare, then its main data is expected to be shown, such as the size of input and output PSV nozzles, the PSV orifice designation, which represents the PSV orifice area, so that we can know the expected capacity a PSV shall handle. In addition, the P&ID is expected to show the facilities needed in order to carry out the maintenance activities. This can be summarized in two aspects: isolation and drainage. So, when an operator wants to open the vessel to perform his maintenance activities, the vessel should be out of service, free from liquid, and the vessel atmosphere should be free from vapor as well. That's why we need to isolate the vessel from the rest of the plant, and this shall be through manual isolation valves, or through removable spools or spectacle blinds. Each of these has its function, and their use depends on the philosophy we are following, the type of equipment, and safety considerations. We also need a drain connection to drain the remaining liquid, and we should determine where this drained fluid shall go. Shall it go to a closed drain system or to an open drain system? The answer to this question shall also be addressed on the P&IDs. We also need a purge connection to prepare the vessel and make sure its atmosphere is ready for the operator entrance. This is usually done through purging the vessel with steam or nitrogen, then with air. All these data should be shown on the P&ID.